was the big, mind-twisting thing that we've been observing. This idea that when you grow a crystal from its mother liquor, that the crystal somehow, as it's growing, structures the liquid in the mother liquor around itself based on its dimensions, its geometry, whatever happens to be the cut axes that it's along. I thought that idea was ludicrous. Like, how could this liquid, which is totally capable of being disturbed and stirred and tilted and messed up, how could it possibly be taking on the shape of the crystal prior to the crystal growing? At first, I was like, this is BS. I didn't believe it. Because it doesn't really make any kind of sense. Like, liquids just don't pre-assemble themselves in that format, unless, of course, you're talking about, say, Gerald Pollack's exclusion zone, which shows the formation of a semi-lattice structure in liquid water, but the mechanism there is absorption of photonic radiation in the infrared and in the ultraviolet wave bands, ignoring almost everything in the visible light bands between them. Now, here's the really weird thing. So these are water-based crystals, Rochelle crystals, and I'll go ahead and activate video. So what I've noticed is when we have spontaneous seed formation instead of a batch that has some issue, like, for example, this one I just started yesterday, and there's one seed in the center that I placed there directly over the magnet, but here's this other one that generated itself and dropped out. Now, the weird thing is that one that dropped out is growing significantly faster than the one that I placed there, and it's trying to catch up. But once it does reach the same size, it'll stop expanding. It'll stop getting larger. And it's following a pretty similar lattice structure to what was in there. And so I've noticed that when I have a seeding tray, whatever seed first shows up, whichever one is the first seed to form on the surface, well, all the other seeds will tend to take the shape. So these are from one batch, and you can see they all have the same shape. By comparison, these are from a different batch. Now, these are all parts of the geometric structure. From overhead here, we can see, and I'll pull this one to the side so it's clear what I'm talking about. I set that there. So this is the natural shape of a Rochelle crystal. It's got many, many faces, many sides come on. I know my phone's having trouble focusing. So that sort of football-shaped thing from the side, that's the shape. But you could take any face along that, you could slice it off, and you'd end up having a geometry. So these are one of those faces, and this is the direction that they started growing. Once the first one dropped out, all the other seeds happen to be the exact same shape. Here's another example. These ones started out as rods. The first seed to drop out was a rod like this, a fairly flat, symmetrical rod. And so all the other ones that dropped out, well, they happen to have the exact same shape too. And so it's super, super weird. What this tells us is that all of the liquid inside of a container, wherever the seed starts, structures itself to follow the exact same geometry of that now growing crystal, and all new crystals that will follow the exact same lattice. But here's a really weird part. If this one, say, is aligned, like, we can see that this one is aligned like this and following parallel to my finger here, well, that other one is tilted a little bit. And so they don't actually have to grow along the same alignment. Their edges won't be parallel, but their shape will be the same.
That is pretty fascinating.
And I should probably point out, most importantly, every single one of these things, these various different crystal shapes, are all using the same exact material in the same distilled water. No changes chemically. These are all the same exact crystalline mother liquor. It's just depending on which one starts first.
Either. You've kept the temperature controlled the same during all of these ones.
Yep, temperature is the same. The saturation levels I have slightly changed, but it seems not to make much difference because I've discovered I can choose whatever seed shape I want, and it's going to follow that one regardless of sort of the saturation level or the temperature. It's a total trip.
That's, it's just so fascinating. Like, is this essentially evidence towards the
fractal nature of the universe, or at least a property thereof?
Yeah, 100% on that. But I'm more thinking of like evidence of water holding memory, that it's remembering and holding the memory of the initial geometry you're putting in, and then from that dictating the law of geometric formation of all the rest that form from it.
Yeah, you could say, it's something kind of like that, but I wouldn't say it's a property of water, because we can see this in materials containing no water whatsoever. They also follow the same fundamental property. It's almost it's almost more of an interaction on the material sciences side with matter against itself and the way that it likes to assemble.
The
And it's
self-organization and
not to do with
structure of
the exact material used, just a property of all matter.
just the self-organization of it when it's taking form into material.
Right. So like this one, for example, this is just, it turned out unbelievable. It's so optically
How
clear.
many Rochelle crystals you two have grown? This is epic in like a week, 2 weeks time.
Yeah, we're going on now. It's like 2 months of various experiments, but didn't really get serious about it until just a little while ago. So I'm going to show what I'll be doing here. Just give me a second. I'll walk over to the computer. So many of those aren't good, and that's because they started out with a seed that turned out not to be perfect, and because of that, there's the reciprocating problem of if you have an imperfect seed that has a flaw, all the other crystals that grow will have the same flaw, which freaking blows. So here's what I'll be doing. So in order to keep these things from having temperature dropout or other issues, I'm going to get some of these heating pads to keep them above ambient room temperature to some extent. And it turns out there's these awesome, super cheap temperature controllers that you can buy as well. And
Nice.
so I'm going to get this 10-pack here and arrange it with all these heat pads on each of those grow trays that we just looked at. And this will allow me to keep them very, very stable above ambient and slowly decrease the temperature as the crystal gets larger, so that, well, finally, we'll be able to grow them significantly larger and get a lot more out of the same volume instead of having to grow them at room temperature and letting them naturally generate themselves. Now, this is going to give us much more optically clear and perfect crystals that we can ramp over a cycle. And we should be able to grow them 4 times faster with this method.
That's amazing. So, like some of the bigger ones you were holding up there, how quickly do you have them growing at the current method and rate?
The fastest rate that I can get at room temperature for a 2-inch by 1.5-inch crystal is probably around 7 days. If I grow them at an elevated temperature, though, and slowly bring them down, so I can basically avoid thermal stresses to a high degree when temperature is suddenly changing, well, I can grow that same 7-day crystal with the same exact quality in about 1 day or 2 days. And I've actually done some experiments to show that I can grow them as fast as 1 millimeter a minute, which is insane. But it's extremely sensitive. And because the heating is coming from underneath on my hot plate there, it's nowhere near uniform enough for the entire liquid. It would have to actually be in something more akin to an oven instead of just being heated from the bottom on a hot pad or a burner.
Gotcha.
But I think we can keep the uniformity of the liquid nice so that we don't have thermals rising from the bottom where it's hot trying to reach towards the top and agitating the liquid, which effectively does destroy the structure of the crystal, which is trying to arrange all the molecules of both Rochelle salts, which is potassium, sodium, as our primary metal catalyst. Then we can get a much higher quality and keep that whole thing stable without crashing.
Right, because you showed in a previous episode there when the temperature did change while the reaction was happening, and then it created those imperfections within the crystal, and then no other new seeds formed in that reaction when the temperatures was changing, correct? It's only when the temperature is staying completely the same that it's starting to precipitate multiple seed crystals forming. Is that correct? Jeremiah, we still got you. You're muted, brother.
Oh, I'm very sorry. Yeah, when I was trying to grow them extremely fast at 1 millimeter a minute, the issue was that heat was coming from the bottom on the hot plate, and then it had to rise up through a volume that was as tall as it was wide, and the heat was only being added at the base. And then, of course, the surrounding walls of the flask and top were cooler than the base, so we had thermals that were rising up from the base and the liquid and trying to balance it out. So that was the issue. It ended up having a gradient in concentration of where the saturated part was and the unsaturated part was, which means that the part away from the heat plate was much more saturated than closer to it. And that meant as the crystal started to grow a little taller, it hit a totally different type of solution, and it would create striations because of the extra added stress of those thermal gradients. Like ideally, the whole body of the crystal in all 6 directions from the center outwards needs to be at the same temperature as what's internal. And the other issue is Rochelle salt, and actually most salts for this example, they will cool down water and endothermically suck heat from it as they dissolve. But of course, if they absorb heat, conservation of energy, conservation of momentum tell us that the Brownian motion has to still be maintained if it's being taken away from a system and put into some other form, and it has to be given back. So as the crystals form, they self-heat the liquid. Now, they form much more slowly than they dissolve. So they may form over the course of 7 days, and I may be able to dissolve them in the course of 30 minutes. So obviously, the endothermic reaction will be far more pronounced than the exothermic reaction, but they do self-heat. However, if I have the liquid already significantly warmer than ambient, that self-heating won't cause thermal stresses because it's hotter than the amount of energy being added back into the water from the crystal.
Okay, I get what you're saying there. That makes perfect sense. What is your next step of deployment use of these Rochelle salt crystals?
Now that I have a crystal which is equivalent to a solid dielectric with no holes or flaws, and I've figured out how to get to that point, and using Liminal's tech to make them exactly the right thickness, the next step is going to be create a series of exactly the same size and shape crystals so that I can profile their capabilities, how much stress electrically I can put them under, how much mechanical excitation I can provide them with, and what kind of photonic excitation might make some changes. And then it's going to be testing their gravitational properties. So that'll be slamming a huge amount of charge across these things in a fairly short period of time, and then discharging them over a different period of time in their charge cycle. It's also going to involve the use of asymmetric electrodes, meaning one electrode is significantly larger than the other. And this is assisted by the fact that crystalline lattice happens to have an asymmetry as well if we cut it along the right axis, or if we simply grow a seed that happens to be along the right axis already using the water height method. We can create both a gradient in the crystalline lattice and a gradient in the electric field distribution from electrodes. And those things together, plus the nonlinear response to the Rochelle crystals, meaning when we put power into them, they'll only respond up to a certain point and then they'll stop. They'll expel other electric fields after the point of saturation and stop producing magnetic fields, which gives us yet another property. We can sort of create that kick or that jerk in physics that we have to have for a non-uniform force.
That's fascinating, and it makes sense. Like, all right, so the whole sci-fi of using a crystal as some sort of like power source of a interdimensional craft or energy or device, you're saying there's actual real potential to that.
I can tell you that the quotes from Star Trek of dilithium crystals used in the warp core, well, there's a lot more truth to that than one might consider. And no, lithium is not the preferred compound, not whatsoever, but you can bind it in a particular way, even though it doesn't like to be stable in that way. And its instability is actually what gives it the ideal properties. So if we optically excite it along one of its facets and excite it electromagnetically along another, then we can release whatever unstable energy is built up into its lattice using it as a power source. But it also allows us to modify the refractive index, as when it begins to decay, it radiates out trapped energy that was put into it, and that will, of course, have an effect directly on space-time because all radiative energy has a mass energy equivalence.
Okay, wrapping my head around that. It's making sense, and that so when you're forming these crystals, are you using the two different sized electrodes into the solution, or that's only applied after you're already taking them out and they're done growing?
So far, I'm not trying to apply any power into the matrix at this point. Seeing how they like to self-structure the liquid ahead of time, I have a feeling it's going to be far more prolific in terms of the formation of these crystals than I originally expected it to be. I was going to do electrostatic charge into this conductive salt solution, which would put the charge on the surface of the interface between both the air and the liquid, and between the liquid and the glass that it's growing inside of, or Pyrex in this case, borosilicate. And of course, the other side of that would have charges taken from inside the liquid and placed on the metal plate that sits underneath the tray or surrounds the tray. But it turns out electrostatics are not really the right way to do this. If I wanted to actually structure the lattice, I would have to place 2 electrodes into the liquid as the crystal is growing and pass a current between them so that I have charges really flowing. And that's going to provide both the magnetic and the electric field to define the lattice structure. So it won't simply be a surface charge thing, or just removing electrons or adding extra electrons like I originally thought. It's going to actually be a current flow thing based on the geometry of the electrodes. It makes it a little more complicated because the salt.
I get exactly what you're saying.
Electrodes. So what kind of electrode do I use inside of a Rochelle salt mixture that doesn't deteriorate? Probably platinum, maybe gold.
Right.
Not sure.
Gold would probably deteriorate too fast, but the gold might then electroplate into the crystal and give you extra meta material properties of it. But yeah, what you're saying is very relevant of what metal to use as the anode that won't corrode in, because you will be essentially doing an electrolysis process with what you just described of running the current between the two in that solution.
Right, and perhaps to avoid a continuous electrolytic reaction, any bubbles that form, any hydrogen gases being released, any kind of perturbation from the process of passing current through this highly conductive salt liquid, salt water, is going to, of course, create major issues. So I have to make sure to avoid the formation of bubbles or the release. And perhaps the way to do that is to form bubbles that are so small that I can uncollapse them or shrink them back down and turn them back into water by passing an alternating current at a sufficiently high frequency pulsed between those plates. And specifically pulsed so that I don't have heating from the current flow, but so that I have an average flow of electrons going back and forth along one specific axis. That should allow me to avoid hydrogen and oxygen generation or electrolysis separation in that liquid, since I'll be forming gases on the surface of the plates that will stick, but then instead of letting them rise up and bubble to the surface, I'll be unforming them on the next half of the cycle.
I get what you're saying. Yeah, that is quite the, I guess, still a bit of an obstacle in overcoming or having to experiment with to get the right method to have it be applicable to this crystal formation, because as soon as you get the bubbling, it's totally going to disturb the solution and the geometry that it formed that was giving you that coherent structure within all of the crystals and seeds.
Exactly. Yeah, it's got to be avoided. The reason I wanted to tell you specifically about this, though, I was so excited to finally kind of stumble across this, because it's been suggested for a while now that the crystal structure is the liquid around it as it grows. But what wasn't suggested, and what I've not heard anybody talk about, is that all of the liquid in the entire container, regardless of whether it happens to be directly around the crystal or not, happens to get structured in what I'm just simply calling right now a super lattice. Because the super lattice allows other seeds to form that are the same shape, but they are not aligned with the original seed. So it's not like there are these virtual, these virtual diagrammatic lines that kind of extend out and force everything to be parallel with itself. It's more like the shape itself is somehow encoded into the liquid and the space around it. And it doesn't really matter which direction it grows in, whether it's 40 degrees or 80 degrees, sideways to the original seed. It tends to have the exact same shape anyways.
Right?
So
that's what's
weird.
So astounding, is that the two crystals will have the exact same geometries in the crystal themselves, but one could be facing directly north as it's forming, the other one could literally be facing 90 degrees or 30 degrees, any degrees.
Yeah, it could be facing southeast or somewhere between there, and it doesn't care. It still has the same shape. That's the part that I don't get, and I hate
the electromagnetic and the magnetic field forces of Earth then aren't affecting it. Once it's got that super lattice structure within the solution, that's the deciding factor that keeps it and affects it.
No, I mean, I've got a 400-pound, ridiculous, terrifying neodymium magnet underneath each one of these trays growing right now, and it doesn't seem to have any effect whatsoever on how it grows.
Really, eh?
Yeah, I mean it's absurdly strong, and like I said, it scares the hell out of me. I don't even like to handle the damn thing because I know if I lose attention for a second and walk by a metal object, like say the shelves that I have all over my room, yeah, it's going to take my fingers right off, and it's got sharp edges. So yeah, I don't. But anyways, it doesn't affect it. That's the main point. Is this fixed magnetic field, this non-changing over time field, doesn't have any profound implications with the crystalline growth. Now, I have a feeling if it was a ferrous material, like ferric sulfate, for example, many different materials that can be made out of that, including a wonderful magnetic dysprosium salt. Now, that would actually affect it. And by the way, there is a ferrous lithium crystal. It's gorgeous, perfectly triangular, bright green, radioactive looking green. And I really, really want to grow some of those. Unfortunately, you can't buy the formulations. You can get the ferric sulfate, and you can get the raw lithium metal. And theoretically, I should be able to make that compound myself. But it would be one of those with a semi-unstable lattice that I can embed with positrons.
Damn. I look forward to your epic neon crystals, but back to the magnet aspect of it. It's what I'm trying to wrap my head around is how the crazy strong magnetic field seems to have zero effect on it. But then if we put in that electric current within it, that can take it to the next level. But I guess it's because it's moving the electrons past it within the solution. That's why the electric field affects it, as opposed to how the magnetic doesn't.
It seems to be that having a dynamic motion is really important. So in the case of passing current, we have electrons physically leaving one electrode and entering the liquid and flowing over to the other. The electrons need not actually leave one electrode to make it all the way through the liquid to the other, because they'll push all the electrons that are free to flow within the rest of the liquid over to the other electrode prior to them ever getting there. In the same way that, you put current into one side of a really long wire, the current that comes out the other side at some percentage of the speed of light is not from the original electron that you put in there. It's not the same particle. It's actually just the pressure of that particle having moved forward, now exerting pressure on all other like charged particles all the way down the line.
I get you.
But without them moving, with the magnet just sitting there, when they move, they tend to, follow the magnetic flux. But the magnetic flux sitting there will not cause motion on its own, so it doesn't really affect it too much.
I see. So then the next test would be maybe moving the magnet around a little bit without disturbing the solution physically.
I think mechanical,
if it affects it.
Like if I move the magnet mechanically with a motor or with an oscillator or something like that, then there's this vibration that's going to be disturbing the liquid, and that's just not going to be good. So it's got to be done directly with either current passing through it or an electromagnetic field sitting stationary from the outside, powered by a coil. But I don't see this working really with the mechanical system unless it was possible to 100% isolate vibration and air disturbance and thermal energy from the motor and everything else.
I see what you're saying. Yeah, just too close to affect the most important variables in it, being the temperature and the motion. One idea I just had that crossed my mind in regards to it's the lattice structure forming and the current going through that aligns the lattice as it solidifies. And that Keshi teaches this with his nano coating and on the outside, and that when the caustic is drying or that nano coating layer, outside shell layer is drying, that they recommend hooking up just a voltmeter to it, not running any actual extra current through it, but just having the voltmeter attached on the positive and negatives on one on each end of it, that just that tiny little amount causes the directional flow and aligns all of the electron paths in the row as they solidify, creating that unified directional fields within the lattice structure of it. And could that potentially be a way for you
metals,
to do it?
Get, right? So if you have two dissimilar metals inside of a saltwater solution or an acid solution, whether you're working with alkali or you're working with acids, you're going to have this differential between different metals. And so if you leave those metals just sitting there and they're not connected through anything, then they're not going to be interacting too much, because whatever free electrons are present in that liquid will stick to the surface and they'll accumulate there, but they won't flow. Now, if you put a voltmeter between them, it's basically like putting a tiny resistive load between them. Most voltmeters are about 10 million ohms of impedance. Fluke tends to use 100 million ohms of impedance, and you can get specialized meters that have 1 tera ohm of impedance, but 1 trillion ohms of impedance. And that means that's the amount of resistance between the black and red wires on your multimeter. Well, that tiny little bit of resistance does finally allow some charges to leave one of the two plates galvanically and flow through the meter to the other, which, like I said, that has a galvanic implication on the surface of the plate. So the meter itself acts like a load. And that's going to allow some charges to flow physically through the solution from one plate to the other as the plates begin to break down. That's probably where you're getting it from by connecting.
100%. You explained it bang on, and that then if you applied that same principle to the crystal as your little differential, would that be a way to avoid the actual electrolysis forming in the bubbling? Just as a first experiment to see.
Well, we're trying to avoid explicitly any kind of galvanic response. So here we're obviously going to be using some non-reactive electrodes. Secondly, they're going to be made of the exact same material and have the same area. And third, we're going to use probably an alternating current that's pulsed for only like maybe 1% of the duty cycle, so that any gases that may form on the surfaces get unformed when the cycle reverses. And so in either electrode, for part of the cycle, we're going to have oxygen collecting on one and hydrogen collecting on the other, and then we'll flip it around. The hydrogen and the oxygen that are on the electrode surfaces will actually become water again, and then it'll flip back around, and the one that had hydrogen on it will now have oxygen in it, and then that'll form back into water, and then so on, so on, so on.
Okay, but I see what you're saying with the AC alternating. What?
We never want bubbles to escape the surface.
Okay, that's cool. I didn't